Good morning everyone. Today's topic is Fourier transform of continuous time periodic signal. As you already have studied the Fourier transform of continuous time aperiodic signal and its different properties like linearity property, differentiation property, convolution property and many more properties. As you already have gone through these properties, so this topic becomes easier to understand. In the second slide, we have discussed the Fourier series representation and its Fourier transform. When we talk about periodic signal, then Fourier series come into existence because Fourier series is basically used to represent the periodic signal. So there are two types of representation. One is complex exponential Fourier series representation and second is trigonometric representation. Here we have used the complex exponential Fourier series representation and it is given by the expression xt is equals to summation k equals to minus infinity to plus infinity ck e to the power jk omega naught t. In this ck is the Fourier series coefficient and it is given by this expression integration over an interval t xt e to the power jk omega naught t dt. Now we have to find the Fourier transform of this representation and it is shown by equation number 1. When we find the Fourier transform of equation number 1, then it becomes a equation number 2. How we have find the Fourier transform of equation number 1? It is shown in equation number 3. Here we have taken xt is equals to e to the power jk omega naught t from equation number 1 here. So now to calculate the Fourier transform, we have multiplied this function by 1. Why we have multiplied it by 1? Because to apply the Fourier frequency shifting property. So to calculate the Fourier transform of 1, we have taken the transform pair from the transform pair table. From that table, the Fourier transform of delta t is 1. Here in equation number 4 and equation number 3, here the 1 is in frequency domain and here the 1 is in time domain, right? So to calculate such type of transform where the domains are different, we use duality property. Using duality property, we can find the Fourier transform of 1 is 2 pi delta omega. Okay, but we have to find the Fourier transform of 1 multiplied with e to the power jk omega naught t. For that, we will use frequency shifting property that we have applied here. After applying the frequency shifting property, the Fourier transform of e to the power jk omega naught t is 2 pi delta omega minus k omega naught. Okay. Now from equation number 6, we have taken this value and we are putting this value in equation number 1 in place of e to the power jk omega naught t and it becomes equation number 2. So simply we can write this expression as summation from k equals to minus infinity to plus infinity ck e to the power jk omega naught t. It is a Fourier series representation of periodic signal and its Fourier transform is summation minus infinity to plus infinity ck 2 pi delta omega minus k omega naught. Okay. Now by using all this theory, we can find the Fourier transform of any type of continuous time periodic signal. So to understand this theory, we have also taken an example to find the Fourier transform of a signal xt is equals to cos omega naught t. Okay. So first we will write the Fourier series representation in complex exponential form. It is given by equation number 7. Now we have to write cos omega naught t in the form of equation number 7, that is in the exponential form that we have written by equation 8. Here cos omega naught t is equals to e to the power j omega naught t plus e to the power minus j omega naught t. Now when you compared equation 7 and equation 8, what we will find? We will find that the value of k is 1 and minus 1 and other values are not defined. Okay. So to find the Fourier transform of e to the power j omega naught t, we will use the same concept that I have used here to find the Fourier transform. So the Fourier transform of e to the power j omega naught t will be pi delta omega minus omega naught and e to the power minus j omega naught t has the Fourier transform pi delta omega plus omega naught. So this is the Fourier transform of cos omega naught t. In the similar way, you can find the Fourier transform of xt is equals to sin omega naught t, and for other periodic functions also. Thank you.